An onboard recorder consists of two modules. A recorder that collects and processes information coming from various aircraft systems, and a crash survivable memory module that stores all of the information. Exclusive standards are applied to the production of the crash survivable memory modules. Nowadays, they're made on high-precision CNC machines. The armored case can withstand loads of up to 3,000 Gs, but the exposure to high temperature can be much more dangerous to the microchips inside. Therefore, one of the most important elements of any crash survivable memory module is the filler, which protects the electronics from the effects of fire. And that's what chemists from the Kursk Avia Optomatica plant greatly succeeded in. Galina Nikolaevna, how can this powder withstand such a powerful thermal impact?
This composite compound was designed specifically to protect the electronic module of the black box and made with highly effective chemicals that absorb heat of 2,000 joules of energy per gram.
So it's an endothermic reaction.
An endothermic reaction of heat absorption. We managed to obtain such a durable protection using a specially selected formula, composition and structure of the composite material.
You know, I have an idea for a non-conventional experiment. Let's see how this powder can protect not just one of the circuit cards you work with here, but a chicken egg. Let's just put it on the block, fill it up, take it to the test bench, and see if the egg becomes boiled after 10 minutes at 2012 degrees, or not.
Let's try that.
All right. Only the crash survivable memory modules undergo the fire test. It's no use burning the entire recorder, but these tests are really stringent. They must simulate the aviation fuel burning conditions in the event of an accident. This test usually lasts 1 hour, but eggs cook faster, so we limited ourselves to 10 minutes. Let's see if our egg made any progress. So, 10 minutes have passed. We're recovering the box. The metal is glowing. That means the temperature of its surface is quite high. Now we're going to cool it in the water and extract the subject of our investigation. We're trying to act fast to maintain experimental integrity, as our research subject is too delicate. And in real testing conditions, the onboard recorders spend additional 10 hours in a chamber at 500 degrees after an hour of fire exposure. Well, where do you place your bets? And what is the temperature on the inside?
140.
140. Well, that's enough time for proteins to coagulate, right? We tried to act as quickly as possible. Let's see. So, all in all, the egg is half done.
Yes.
So, the egg didn't become hard-boiled. 2012 degrees for 10 minutes.